Today we're going to go through a really quick demonstration of Model Shop. And the use case we're going to use is an on-demand analysis model for a residential loan portfolio. A few features of this model are we're going to pull in some personal credit data about the mortgage holders. We'll do some machine learning to get granular information about which mortgages are most likely to default and most at risk. And then we will roll that up to a portfolio level view as well and run some simulations to understand portfolio impact. So let's get into it. So here we are in the Model Shop browser. Here we can see the models that we own as well as models that are shared with us. We can also start with template models. And in this instance, we're going to be using consumer credit. So we're going to start with a model that has been pre-configured with some TransUnion starter variables as well as data. I'm going to duplicate that template. And now I'll just rename it to Real Estate Demo for this demo purpose. And then we can open the brand new model. Once it's open, you can see that Model Shop is pretty blank waiting for our logic. Let's take a look at our credit report. It's sparsely populated, but there's actually a lot going on behind the scenes. We have a full XML credit report on each one of these records, and we can extract the variables that we want. Let's start with a FICO score. So we make it really easy. Like I said, this is all an XML file behind that's pretty complex. Anybody who's ever used a credit report before knows the level of complexity. So I'm going to filter through a lot of the objects here, and I'm going to find the score, which is the FICO score. And then what we can do is we can simply just drag that variable onto our editor. We'll change the type to integer. And now once I click save, we have a new field in our model called FICO, which is the FICO score that's extracted from that credit report for each one of the credit reports we have in this list. We can do more complex calculations where we can bring in things like trade line variables. So let's query the trade lines and find all the total mortgage debt for each one of these credit reports as well. So we're finding all that are tagged as a mortgage and that are open, and then we're summing up its current balance. It's a currency, and then once again, once I save that, that variable is added to the model as well. But we are not just trying to create credit variables. That's one piece of the model, but we also need to bring in our mortgage portfolio data. So Model Shop can bring in information from files, databases, or web services. I'm going to bring in a file from my local file system. It's a CSV file. Load it in. We can preview it. If there's any cleanup that we need to do in terms of headers, footers, or field mappings, we can handle it here. But let's load it. And now you see instantly we have our mortgage portfolio data. And it looks very similar to our credit report data. We can filter through, we can sort it. All the things that people are used to doing in spreadsheet tools, frankly. But what we really need to do now is link it with our credit data so that we can merge these things together and use them in conjunction with one another. Model Shop provides a link wizard, and it's actually giving us a hint here saying that I've found common data in both these items. So we're going to accept the link that it's suggested to us. And then once we've made that change, you'll see that the loan ID has turned blue. That denotes that the link has been created between the mortgage record and the consumer credit record. We can see this in action by adding a new field. And let's just map over quickly the FICO score that we just created on our credit report. So I can go to loan ID, which is now our link field into our credit report, and grab the FICO. And once again, when I save the model, now we have another field on our mortgage portfolio this time, that is our FICO score. Additionally, we can traverse the model as we did with our trade lines before. So let's say we want to figure out the number of mortgage trades for each one of these mortgage portfolios. So once again, go to our loan ID to get to the credit report. Then we can go into our trade lines. And just as we did before, we'll find all that are open and a mortgage. And then we can call a size function on that, which will just return how many mortgages are found in that list. So now we have the beginnings of our model. We have credit report data as well as our mortgage portfolio data. We can visualize it in the model graph and see those pieces coming together. But what I'd like to do now is pan over to the same model, but a more complete version with an hour or two of work behind it. As you can see, this model looks very similar to what we had before. Let's take a look at our model graph. And we still have our mortgage portfolio data and our credit report, but now we've added some additional information. Loan projections, our risk curves, as well as servicing history and scenario data. Let's actually take a look at our credit report while we're on the topic of visualizations. And I want to take a look at our dependency graph. So in ModelShop, we keep track of all the dependencies in a calculation. And it's really helpful that we can trace through our model to understand how calculations are being made. So we can follow this all the way through to its source data to try to understand what is impacting a certain calculation. So let's get back to our model. I'm going to switch over to our mortgage portfolio list, which is what we imported in our previous step. However, as I pan over to the right, you'll notice that we've supplemented it with a lot more information and calculations. Probably the most important is this loan projections calculation, where we are dynamically creating records for each period in the term of each one of our loans. So a 360-month mortgage will have 360 periods created. And that allows us to map in a default curve and do cash flow based analysis on each one of our loans and really get granular with our analysis. And the way that we do that is through machine learning. You'll see that we now have a default prediction here. So how are we bringing that together? What we've done is we have created a machine learning model based on a servicing history showing who has defaulted, who has prepaid, and when. We can use H2O or Python to train a model to derive value from this information, and then we can deploy it right back into our model so that we can figure out who is most likely to default, who is most likely to prepay, and where our risks lie in the portfolio. So when I train on this data, we come back with what variables are most important for making those predictions, some information about the accuracy of the model, as well as a confusion matrix to see how our actual predictions panned out. Then once our model is trained, we can use that runtime model, just like any other calculation in ModelShop, to make predictions on who is likely to default and who is likely to prepay and when. With all these pieces in place, now we can use ModelShop to simulate and optimize our portfolio. Here we have our standard default curves in our base case. But let's see what it would look like in a recession, so high unemployment and low interest rates. Once we do that, we now have our new curves added to the graph. And we've also identified which mortgages are most at risk in this scenario, enabling proactive action to mitigate losses. This is even more likely since everything in ModelShop is wrapped in a REST API. Everything you've seen, every piece of data, calculation can be accessed through external links. So here's an example. I'm going to copy the URL for just the at-risk loans that we viewed here. And we can pull it in through a quick REST call and get it back in 100 milliseconds.